control the visibility of the light object. So let's go back just a bit so that you can see the actual area light. If I reduce the opacity down to 0, you can see the object itself is no longer visible for the render engine. The illumination, however, remains. And finally, LightPass ID is a parameter related to multi-pass rendering. It is an option that has been discussed in the multi-pass series. Let's continue the discussion with the distribution parameter. With this option, we control the pattern of generated light. A popular usage is creating go balls, or in other words, cookie cutter effects. It can work with any shader or external images loaded via the image texture node. Let's take a look at an example setup. Under distribution, go ahead and assign an image texture node. Let's feed it an external image, which in this case will be a black and white image of a window frame. And you can immediately see something happened, but it doesn't seem to reflect the image we loaded. Let's zoom out just a bit to get a better perspective. The reason why this image doesn't match the generated light pattern is because the projection is wrong, and we can easily fix that via the projection node. Under texture projection, let's change the type to perspective, and this is now much closer. There is, however, a little problem. As you can see, the image is styling, which is an effect we don't want for this example. So to fix this, let's first minimize the projection node. To fix the tiling, go under border mode and change the parameter to black color. Next, as basic lighting theory says, the smaller the light source, the sharper the generated shadows. So in order to better observe this light pattern, we need to reduce the size of the area light. Select the area light, go under details and reduce the outer radius to a value of 5. And there we go. Let's go back to the default camera view. I will move the live viewer, switch to top view, select my light, and if I now move it around, you can see the light pattern follows as expected. We continue the exploration of the distribution parameter with IES lights. These are special files used to mimic light patterns generated by real-world objects. Let's take a look at how this actually works. We'll continue working with the same scene, with the difference that now the area light is centered on top of our objects. To use IES files, we need to utilize the Octane image texture node. Let's open it up, and now it needs an IES files. Let's use some of the files that come integrated with Cinema 4D. Open up the content browser, select presets, search, and look for IES. Select a file you like, drag and drop it inside the image texture node, and there we go. If I now grab my area light, switch to top view, and move it around, you can see the specific IES light pattern follows around. There is, however, a small problem. Let's zoom back. If I grab my light and try to rotate it like this, you can see the IES pattern doesn't follow. And the reason for this is that the projection of the IES file over the surface of the area light is wrong. To fix this, select the image texture once again and use the projection node. texture projection needs to be set to spherical with a rotation of 90 degrees. Things are now back to normal. Let's once again grab the light and move it around. The pattern follows as expected. Let's try rotation, and there we go. These are the basics of using IES files with Octane Render. In this one, we'll take a look at efficiency or texture. With this parameter, we control how light intensity and color are mapped across the surface of an area light. We'll continue working with the same scene, with the difference that the shape of the area light has been changed from rectangle to